All right. Okay, well, welcome everyone to session 4 of learn.py. Today we are going to be covering file IO and automation. So hello, I am your first trainer for today. I am Jody, and then we have our second trainer.
Hi guys, my name is Eric. I'll be your second trainer. My goal is
Yes.
to bench 135 pounds.
Yes. Okay, so Eric will be benching 135 someday, but you guys are going to be benching some knowledge about Python. Also, can everyone see my slides? Okay, yes. All right, let us get started then. So here are the link to the slides. If you want to follow along, you can look at those. And then we also have the README. If reading is more your style, you can take a look at that. I will leave it up here until perhaps one of the mentors drops it in the chat. All right, thank you, Eugene. And then the membership portal attendance code for today is Swole Eugene. So yes, go claim your membership points for ACM. And then we also have a feedback form. Please fill that out. We very much value all your feedback. All right, so overview of learn.py, we have reached the file IO and automation section. So the previous workshops in learn.py covered a lot of syntax in Python, along with like just the basic core concepts of how to use it as a language. So today we'll be still covering that for the first half, and then the second half we'll be getting into sort of our first applications of Python. And this is what makes Python such a powerful language, is that once you have all of these like core features down, there's going to be a lot of packages and libraries. If you don't know what that means, it's okay, we'll cover them, that you can use, and then you can get really cool things like machine learning models or things that like click on your screen for you. Lots of cool things. So that is today. So today is file IO and automation in 2 hours. This is definitely a Chloe Ting ripoff. So I hope you enjoy. You'll get a brain workout from this. All right, so the plan, round 1 of our workout, we're going to first cover modules, then exceptions and exception handling, and then we're going to cover file IO. If you don't know what any of these words means, like that is okay. We will be covering them. And yeah, that was round 1. Round 2, we'll be getting into timing and scheduling in Python as well. And then Eric will cover a really, really cool text bot demo. So stick around for that. And hopefully by the end of this workshop, you will have like your own version of this that you can run and use as well. So you guys will be able to take home something today. All right, so let's just hop right into this. Oh, as always, by the way, if there's questions, please drop it in the chat or feel free to unmute. If you drop it in the chat, I will do my best to answer it, or a mentor may get to you first. All right, let us get started. So modules, what is a module? A module is just a way to use code from other files. So if you have a really long Python program and it's, 7,000 lines long, it's going to be kind of hard to scroll, find things, hard to keep organized. Say you're working on a project with someone and they're like, yo, here's my file. You can copy from it, plagiarize from it. Oh, we don't condone plagiarism here at ACM Hack. But you probably want to keep that in a separate file from your own. Yes, modules gives us a way to do that. So a way to use code from other files. All right, so how exactly do we use modules in Python? So let's just say we have 2 files here. Let me get my pointer pulled up. Let's say we have 2 Python files. We have one called coolmodule.py and we have main.py. And notice that these are just regular Python files. There's nothing special about them. But from now on, I'm going to be referring to coolmodule.py as our module. All right, so what is this module file? It's going to have some really cool code in it. We're going to print beep boop, and then we're going to print Eric is cool because Eric is really cool. And then we're going to have a function definition called boop that just prints boop boop. All right, so this will be our module file. No, like it's just a regular Python file, but we're calling it a module. And why are we calling it a module? It's because we're going to import it into our main file. So I'm just calling this main.py as just a indicator that this is sort of the main file we're working in, but you could also name this anything. And this is how we import it. So notice we have the name of the module, coolmodule.py, and all we write is import coolmodule. Notice that we drop .py. So here we don't actually need that file extension. You just need the name of the module. And then to use a function from within this module, you just say the module name, cool module, dot, and then the function, so dot boop. And similarly, if this was a class, you could call the class the same way, cool module dot, like the class name. Or if there's some sort of global variable here, you could also reference it the same way, cool module dot, and then that variable. All right, so we just showed you one way how to import a module, but there's actually a few ways to do it. The first way is the way we just saw. So import the name and then name dot the function you want to use. All right. And then the second way to do it is this syntax from the module name and then import the function, class, or variable that you want. And notice here, when we directly import this function, we don't actually have to say cool module dot like boop anymore. We could just directly call boop. So this is importing a specific function. All right, and then the third way is import cool module as CM. So we're going to see this as keyword a few times in this workshop. What it is it's just a keyword that allows us to rename things. So we're renaming this module cool module to CM. So we're going to call boop via cm.boop instead. You'll see this a lot in Python code because there's going to be a lot of packages or libraries that you're importing. And when I say packages and libraries, I'm really just referring to modules code that other people have written. We oftentimes don't want to just keep typing cool module dot something, cool module dot boop, cool module dot yeet. It's getting, it's kind of annoying to type that. So we usually rename it to something shorter. So this is something you'll see quite often. And then there's one last way to import things. It'll be cool module, or from cool module import star. And then from this, you can import the individual functions as well. So in cool module here, we got boop, and we also got yeet. And this star just means import all. So individually import every function, every class, every global variable from this module. So this is also another way you'll see it. Generally, this is not recommended for a few reasons. One is that the code is less clean, so it's really hard to tell which functions came from which module because you're just directly calling the function name at this point. And then the last way is that you could import a really big file when you really only wanted a few parts of it. So say you import a giant module with a million lines of code, but you really only want to use, their beep or their boop and their yeet function, you've sort of imported a lot of unnecessary things. So generally not recommended. Python docs also don't recommend you use this method. All right, so let us get into a demo just so we can see what this looks like in action. So let me pull up my VS Code. So I'm just in VS Code right now. I have made a folder to work in, and I'm just going to create a new file. I'm going to call this main file main.py. All right, hopefully this is big enough so you can see it. This will just be the main file that we run code through. And then I'm going to create a few modules. We're just going to start off with one for now. The first module, let's call it chloeting.py. So I want to define this module to be a Chloe Ting workout, right? So, lately during pandemic, I figured it's time to work on myself. So I've been, following some Chloe Ting. So this is a Chloe Ting workout. And let's just define a few functions in this Chloe Ting workout. Oh, actually, before I do that, let me print, we are loading a Chloe Ting workout. All right. And you'll see what this does in a moment. And then let's say def. Chloe Ting does some cool things. She does some push-ups. So we'll have a push-up function. We'll just have it print do 10 push-ups. Chloe Ting also has some sit-ups. So we'll do a sit-up function, print do 10 sit-ups. All right. And then lastly, some squats as well. So Chloe Ting will have a squat function. Print do 10 squats. All right, pretty simple. This is nothing fancy. It's just a file, and we have written some very basic functions in here. All right, so now let's load these into main.py. So the first way we mentioned was import just the module name. So we got Chloe Ting. All right. And then to access each of the functions in it, we're going to say Chloe Ting dot. And then I had a function called push up. And then I have another one called sit up. And then lastly, I have one called squat. All right. So when we run this code, so I'm going to open my terminal now. Give it one moment to load. When we run this file, we can see what the output is. So running Python 3 of main py, we're going to see we are loading a Chloe Ting workout, do 10 push-ups, 10 squats, or 10 sit-ups, and then 10 squats. So let's just break this down real quick. We see this first line, we're loading a Chloe Ting workout, and that is from this original print statement up at the top of our module. Why is this printing out? So basically, whenever you import a module, what it's going to do is it's going to run this whole, like when it copies it in, it's going to run everything in here. So if you have any like print statements or code that's at the beginning, that's going to run once. And I say once because notice no matter how many times we call like any functions from it, that initial print statement here only ran once, right? So everything runs once, everything gets initialized once as well. So there's that. And then the other way we could do it was import Chloe Ting as if we wanted to make it shorter because typing Chloe Ting is kind of long. Let's just say CT. And then I can change all of these to just say ct.pushup, sit up, and squat. So I'm going to do some fancy multi-cursor stuff. All I'm pressing is Alt and then clicking down the lines, and I have a cool multi-cursor. So ooh, I feel very powerful doing that. All right, we're going to save it. And if we run our Python code again, we see the same thing runs, loading Chloe Ting workout, push-up, sit-up, squats. And then finally, our last way that I mentioned, I'll just go through it real quick. From Chloe Ting, import push-up. Let's also import sit-up, and let's import squat. All right, so now we're just directly importing the functions. I'm going to fancy multi-cursor again. Oh, I said Windows is Alt. I believe Mac is the Option key. So Option key and then click. All right, so now we're just going to directly call the functions because we directly imported them in. And then when we run this code, same thing, code works just fine. All right, so this is very simple, but let's make this a bit more interesting. So let's define a second module. We're going to call it, what do you want to call it? Mom workout. And why a mom workout? It is because my mom is a kickboxing instructor and she is very cool and she has her own workout routines. So this is Jody's mom's workout routine. All right, so my mom does kickboxing, right? So one of the things she does is kick. So print, I will kick you. My mom will probably not actually kick you. She's a really, really lovely, amazing, smart person. But yeah, she could probably kick you really hard if you, I don't know, tried messing with her. All right, another thing she does is punch, because kickboxing, right? So print, I will punch you. Like I said, she probably will also not punch you because she's an amazing person. But, if you mess with her, she could probably hurt you pretty bad. And then the last one, my mom also has great arms. Why? Because she does a lot of push-ups. All right, so we're going to print, let's see, I will do, let's say, a conservative number, 1,000 push-ups. Right. Could she do 1,000 push-ups? Probably. Actually, I don't really know, but it's okay. So let us change this one more time. So I'm going to go back to importing the way we did before. So Chloe Ting. And then import not Jody's mom's. Mom workout. All right. And so to call these functions, we're just going to type, let's get this going. We're going to type Chloe Ting dot pushup, and then my mom workout. We mom workout. That's mom workout dot pushup, and then she doesn't have any of these. She only has pushup, but she does have kick, and she does have punch. And you can see it's really easy to tell which functions come from which module because we're prefixing each of the functions with the module name. So now if I run this, if all goes well, we see we are loading a Chloe Ting workout. And then we're going to do 10 push-ups, 10 sit-ups, 10 squats, and then 1,000 push-ups. I will kick you, and then I will punch. Well, I meant to type I will punch you, but similar idea. And let me type in the print statement here so I can just prove one more time that everything loads at the beginning. So we are loading Jody's mom's workout. And recall that I have to put in these backslashes to escape the string character. Okay. And then let's also fix this for consistency. I'll punch you. All right, so if we look at our console output, so I just ran the main file again, we see that we load in both the modules on the top. So those print statements ran, and then we ran the workout stuff. All right, this is very simple, but let's make it a little more interesting. So here's a question for you. What happens if I do something like this? From Chloe Ting, import push-up. Okay, well, push-up. And then from mom workout, import push-up. Okay, now the question of the day, which push-up is going to be called? Is it the Chloe Ting? Will I only do 10? Or will I die today and do my mom's 1,000? Drop your answers in the chat now while I save this file. Okay, Chloe Ting's push-ups or mom's push-ups is a question. All right. Okay, well, while you're thinking about this and going, which one gets called, I will just do what regular programmers do when they don't know what happens. We're just going to run it and see what happens. All right, so when we run this, we see we're loading both of them, and then we're doing 1,000 push-ups, which means we are doing my mom's workout. That comes from the mom workout module. So why is that? The reason is when we first import Chloe Ting and we import push-up, push-up is going to refer to the push-up function from the Chloe Ting file. And then when we have the second import line, from mom workout, import push-up, push-up is now going to refer to the push-up from my mom's workout. So it's essentially going to overwrite the original one. And that's why when we call push-up, it's going with this second one. So if we switch the order of these, we'll see that the function should switch as well. Right, so we'll import push-up from my mom's workout, but then we'll override it with Chloe Ting's. So we'll see we're loading Jody's mom's workout, Chloe Ting, and then 10 push-ups. And 10 push-ups is from the Chloe Ting workout. All right, so that is it for modules. If there's any questions, please ask them now. If not, it is poll time. Yeah, I'm going to launch a poll right now. This is a quick, short poll. Shouldn't be too much. Oh, there's another poll supposed to launch at the beginning. I'll make Eric launch it. Okay. All right. Let us launch this poll. I will give you about a minute or two. This one isn't designed to be too long. It's just a review. So let us begin with that. I can also pause the recording, so prepare for that sound. All right. Let us continue. Oh, and I see a question. Yes, it looks like Tim has answered it. Thank you, Tim. All right, moving on to exceptions. So this is a new topic. We're moving on from modules now. Exceptions. What are exceptions? So these are errors detected during code execution. So you've definitely seen these before if you had like some sort of, like you use a variable or you mistype the name of it and Python stops and goes, oh no, that's not a variable you defined. And you go, oh, I'm sorry, I spelled it wrong. Stuff like that, it's an exception. So things that happen while your code is executing and stop your code because it breaks. So this is a list of common exceptions. So dividing by 0 will stop your code. Computers also don't know what to do when you divide by 0, just as mathematicians tell you don't divide by 0. And then we have referencing a variable that doesn't exist. So if you misspell the name of your variable, Python goes, I don't recall you defining it. If we have accessing an index out of bounds in a sequence object. So if you have a 3-item array and you try to access the 4th or the 5th index, Python will stop running and say, yo, nothing exists there. You can't access out of bounds. And then finally, accessing a key that doesn't exist in a dictionary, it's a similar concept. And there's many, many more exceptions. So if you're curious to know what kind of things can break your code, then check out this link. This is just a link to the Python documentation. But yes, there's many, many defined there. So I'm just gonna show a quick demo. You guys have definitely all seen these before, but for consistency, I'll just show what it looks like. I'm gonna make a new file called exceptions.py. And oop, there's a loud car driving by my apartment. All right, so some exceptions examples. So I'm just gonna do a quick few easy ones. If I do something like 1 divided by 0 and I run this file, Python 3, that's not how you spell it. We get this, I'll pull up my console, 0 division error, division by 0. So my code breaks. If I try something like, let's see, a plus 19, and I run this code, we'll get another error. Like name A is not defined. So we got a name error this time. And notice we don't even try run this 1 divided by 0 this time because we just hit a line that broke, and then we just exited the program. Name error, name A not defined. All right, so nothing too crazy there. We've mostly all seen that, I believe. So what is happening? Remember, exceptions will stop the execution of your code. So if you do something like dividing by 0, your code is going to die. But wait, this is kind of annoying. Like every time, like say you make a mistake or the person using your program puts in something wrong and it causes your program to crash and you go, oh, that's so annoying. Like what if it could just, keep going and we don't have to worry about this? So we have something called exception handling. So exception handling allows us to, when an exception occurs, execute some code. So a specific code we tell it to execute and then continue with the program. So instead of dying, we'll be able to handle this exception. So because we're handling exceptions, we won't have this whole mess of dying. And some people have really bad choices in how they handle their real life problems, but we're not getting into that today. We're just going to handle Python exceptions. All right, so handle exceptions. What does this mean? As a summary one more time, when an exception occurs, instead of stopping our code, execute some other specified code, and then we're just going to continue. All right, so when we divide by 0 now, instead of dying, we'll just continue on. All right. So this is how we handle exceptions with this code block. This looks kind of like a lot, but it's actually quite simple, so I'm going to break it down. So we first have this try block. Let me get my cursor. Okay. We first have this try block. And in this try block, we're going to put any code that could possibly raise an exception. So it might throw an exception, it might not, we don't really know. We wrap it in this try block. So we're first going to execute this code. And then we have this except block. So this code in this block will only execute if an exception is raised. So say this line up here throws an exception, raises an exception, then we'll print this. If not, it's just going to skip over this block. And then we have this finally block. So this code in here will always execute regardless or not if an exception was thrown, right? So this code executes regardless if an exception is thrown, right? All right, so there's those 3 parts of this try except finally block. Let us zoom in on part of this though. Let's just zoom in on this specific except exception part. So we see except exception. What this is specifying the specific type of exception that we're going to be handling. So when we say exception here, the word exception accepts all type of exceptions, like They're all under this one type called exception. So this catches all exceptions, but say we wanted to catch a specific type of exception. For example, if someone divides by 0, we want to tell them, hey, don't divide by 0, a very unique one for that unique error. We can specify the specific type of exception to handle. So right here we see this 0 division error, and we'll only execute this one block if we divide by 0. And note that once we execute this block, so we catch it, we handle it, we're not going to execute the one below. We've already handled the exception up here. We're just going to skip past anything else that is listed. And then finally, we'll execute that finally block. And if you're wondering, how do I know like the 0 division error? This is just something that's built in. There's a nice long list of built-in exceptions. Built-in exceptions on the Python documentation. So you can take a look in your free time. There's a very long list. You can look at that. So let's go into a demo of how this looks as well. So we are going to pull this up. All right. I'm going to just use this file again. So we're going to have a try. Let's just do something simple like 1 divided by 0. And then except, exception, print, yay, exception, handled. Woo. And then finally, we'll say print this always prints. All right, so let us just run this file and see what happens. So if all goes well, we'll see that, yes, so this will raise an exception, causes a problem. But instead of crashing our code, we'll handle it. So this got executed, the exception handled. And then finally, the finally block prints as well. And if an exception wasn't raised, so if I just did something like, I don't know, 1 plus 1 equals 5, this code is okay. If we run this, we'll see this block was not canceled. So we just printed this, or if we ran this, and then finally this always prints. All right. And then recall I said we could handle specific types of exceptions. So if I do something like except 0 division error, print, oopsie, you divided by 0. So if we execute this now, 0 division error is not defined. Did I spell that wrong? Is there an I? Aha, there's an I. My bad. All right, oopsie, you divide by 0, and this always prints. Okay, so oopsies divide by 0. Note we skip over this one. Exception already handled, execute that finally block. All right, that is it for this example. If there's any questions, as always, drop them in the chat. All right, let's move on. Raising exceptions. So sometimes as a programmer, you want to purposely manually raise an exception. Maybe, you're handling some input and then someone gives you bad input. You just want to raise an exception. You want to crash their program. In that case, we can, raising exception is when you want to make and use your own custom exception. All right, so the syntax of this is raise and then exception. You can raise this general exception, or you can raise a specific type of instruction. For example, there's one called value error. And then you can also pass in your own custom error message to here. So like your custom error message. But note, for a lot of these built-in functions, you don't actually need to pass in any specific error message. You can just leave it out like this. So raise value error. And then you don't need the parentheses at the end. But yeah, it's the same thing. It's just one has a custom message. And then if you're not satisfied with the built-in exceptions, maybe, you've got a really fancy program and you have like a really specific exception that you want to define yourself, then this is how we do it. So let's break this down. We're going to have a class. Let's call this workout error. Exceptions are commonly called something, something, and then error. Don't ask me why they don't call it exception, but they're usually called error. And we're going to inherit from the exception class. So if you recall from last week, from classes and inheritance, that session, by putting a class name here in the parentheses, we're going to inherit all of the methods and properties of that class. So this class called workout error is going to behave exactly like another exception now, except for the fact that we've customized it a little bit. So let's look at how we've customized it. I have this comment here. We didn't really have to define this attribute. That is referring to this attribute called message, this parameter here. You don't actually have to add your own custom ones. You could have just left an empty init function. But I decided to add one here. So message, and then I said self message equals message. All right, and I'll show us how we can use this in a second. And then to raise this now, we say raise workout error. And because I told us now we have to pass a message, pass in your own message here. So workout error, I don't want to work out today. Actually, I do want to work out today. It's been a while, you know, so it's time to work out. So let's define some custom exceptions. All right, so we got class, I'll just do the one from the slide, workout error, inherits from exception. And then I'm going to define that constructor, I can speak really well today, self message, and then this will just say self.message equals message. All right, I'll show us how to use this in a second. So if I want to raise this exception, I just say raise workout error. So if I run this code now, so it's going to be handled by this general exception block, right? So accept exception right there. And then we can see the output just as, yay, exception handled, this always prints. If we want to catch the specific one again, we could just do, let me just add it here, except workout error, print workout error. We'll handle that specific one. And then sometimes we want to see like the actual error itself. And right now we're just printing out some sort of message. So I can use the as keyword. So if you recall, the as keyword can let us rename modules. We can also accept an error, like catch this error, and then save it in a variable name. So this is very common. You'll also see this a lot. So accept, let's call workout error as E. And instead of printing workout error, let's just print out E and see what happens. All right, so if I print out E, let's raise workout error with, also I realized the exception that got raised was not that I raised workout error, but probably because I raised workout error without passing in a parameter. No, let me go back. So because workout error takes in a message as part of its constructor, this is mandatory. So let's just say I don't want to work out. So an exception was raised because I called the exception wrong, but similar idea. All right. Workout error. Yeah, I did print it wrong. All right, so we're going to accept workout error as E, and we're going to print E. If you guys are confused by that, I apologize. All right, let's catch that. Okay, so we caught workout error as E, and then we printed E, and we can see here that it prints out that custom message that we passed in. So that's a way to view the exceptions that you are catching and handling. Yes, and if you hear me say catch, it's because in other languages, the try except block will commonly be something called a try catch block. So it's the same thing as that, but new words. Okay, any questions for that? All righty. So it is once again poll time. So just to review what we have gone over, let us do a poll. I'm going to pause the recording. Here we go. All right, so we have one last concept before we go into our break, and it is file I/O. So this is the third part of round one of our workout. All right, so if you're going, what is file I/O? File I/O is a fancy word for file input and output. And if you're still going, what the heck is that? That's okay. These are just fancy words for how to read and write to files. So how do we read and write to files in Python, right? So why would we ever do things manually by hand, clicking your laptop and new file, name it, whatever. Why would you do that when you can do it programmatically, right? Okay, so how to do file IO. There's 3 very simple steps. The first is open the file. The second is read or write to your file. And the third is close the file. And you're probably sitting there going, wow, I just totally got scammed into looking at this slide. Like, no poop, that's how things are done in real life as well. But actually, this is how you do it in Python. Just these 3 easy steps. So let us get into the details. So first we have opening the file. So this is the syntax for that. So we have a file. We're going to say f equals open test.txt with this W thing at the end. So I'll break this down. Let's look at what's happening here. So this open method is something that's built into Python. And when it's called with the proper parameters, you're going to get a file object return. So what is a file object? It's just something that's going to allow us to interact with the file. So anything we do now to the file, like reading or writing, whatever, is going to be through this file pointer f. So file pointer, file pointer. And then open takes 2 parameters. One is the name of the file itself. So pretty straightforward, test.txt. And then this third one, this letter W, is the mode. So you can pass in different letters here and they mean different modes. These modes just control whether this file pointer is going to allow you to read, write, or append to the file. And there's a few other modes as well, but these are the most basic ones. And if you want to learn more about open, you can check out the Python docs here. There's actually a lot of other parameters involved, but most people don't ever touch them. If you're curious, though, you can read about it here. All right, so next we're going to read or write to the file. So right now this W means write, so we are in write mode. So I can call f.write and boop. So if I try add boop to the file, it should successfully add the word boop into the file. And there's a few notes about this. All right, so write writes the word boop to test.txt. It's going to overwrite anything that existed before. So overwrite the file if it already exists. So if you had test.txt and it had other text, I'm sorry, your text is gone. It's going to say boop now. And if the file doesn't already exist, it will actually create a new file. So that is another thing with this W. If we wanted to read instead, we're just going to change the mode to an R. R means read, and we can read this. So read contents of file and store in variable data. So that's what this code is doing, f.read, storing it in a variable called data. So say the file said boop, and we can read out the word boop. Another few things about this will raise an exception if the file does not exist. So if we try opening a file that doesn't exist in read mode, you'll get an exception. And then these are a list of all the modes here. You can look at these in your free time. I'm not going to get too much into detail because they're mostly self-explanatory once you figure out which one you need and which one you need to use. So this slide is just here for reference. This is a direct screenshot from the docs. So if you're curious to see where this came from, read more about it, you can always check out the docs here. All right, and then finally closing our file. So we're just going to call f.close. And what that's going to do is that's going to basically get rid of this file pointer file object. So this file object will be no more. We won't be able to access the file anymore through this at all. So if you try to do something like f.write boop, try to write boop to it, it's going to cause an error and you're going to be really sad. But that is because we've already closed the file object. So can't do that. So close is very important. And note, we should always call close. If you don't call close, one, other parts of your program can mess with your file object and modify your file in ways that you don't want. Also, Python documentation specifies this. If you don't properly call close, any writes you do to the file might not actually fully execute properly. And you might not get everything written to your file that you wanted. Even if the program successfully runs and exits, this write could fail if you don't close properly. So very, very important. All right, so let's get into a demo with this as well. So let's open this. I'm going to make a new file called file.io.py, and we are going to look at some sample file.io. So let me just pull this up. All right, let's just do an easy one first. So f equals open. Let's create a new file called Eric info, and we're gonna open it in write mode. I want to write to this file, and then f.write Eric is a gym bro. He claims he's not a gym bro, but don't actually know if he's telling the truth. All right, let's run this file. All right, so if I say python3 file.io.py, if I run this, we'll see if you blinked, you didn't notice it. I didn't notice it because I blinked. But there's a new file now called Eric info. And if we open it, it says Eric is a gym bro. And it also defaulted to a .txt file. I forgot to specify that. I can make a .txt file right now. Yeah, now we have Eric info.txt. Let me just delete this old one. You don't need it. Yes, move to recycle bin. Yeah, and it has the text exactly the way we wrote it in. Eric is a gym bro. You wrote in Eric is a gym bro. All right, another example of the read. Like if we said f open Eric info dot text in the read mode, and then I said data is equal to f dot read, and we can print this data, and then we can close this f dot close. All right. So if I run this again, we will read Eric is a gym bro, and that gets printed out here because that is exactly what we had in there as well. And for example, if there was like a lot of stuff in this file, I'm going to comment out this write stuff. I don't want anything to get overwritten. If there was more than just Eric is a gym bro, if we also said something like Eric will bench 135, this will also be read in through this as well. So if we run this again, we see Eric is a gym bro, new line because we're on a new line now, and then Eric will bench 135. So yeah. All right, that is pretty straightforward. Any questions? Okay. Oh, I forgot to go into one more thing. Let me do that real quick. Also, if we try open a file that doesn't exist, so I did something like f equals open, this does not exist in read mode, specifically read mode, by the way, our code will have an exception. File not found error, no such file or directory, this does not exist. So yeah, okay. Let us move on. All right, so we noticed before that during file IO, we can also have exceptions occur. So let's apply what we just learned with exceptions and do some save file IO. So we're going to use the try except block. So it's going to look something like this. We're going to try, then we're going to open a file. And if we successfully open this and get a file object, let's try again, and we're going to write to it. And then finally, after this is all done, we want to close this file pointer because we don't need it anymore. And then if there was some sort of exception thrown during this whole thing, let's catch it, let's accept it, let's handle it. And then we're going to print, error opening the file. So this is save file IO. And you're probably going, oh my God, I don't ever want to do that. That's so safe, but oh God, that's a lot of code for literally writing the word boop. So we're going to introduce something called the with keyword. So the with keyword, what does it do? It's going to automatically close the file object when we are finished with it. Let's just take a look at what this looks like. So we have some context. So with open test.txt in write mode as f.write boop. So let's break this down real quick. So with open test.txtw, we're going to get a file object as this as keyword keeps popping up. We're going to store that file object in a variable called f, and then we're going to f.write boop. And after this with block finishes, it'll automatically close the file object for us. So it doesn't necessarily called f.close. Internally, it calls another function, but just know it does the exact same thing as f.close. So this is safer and it's fewer lines of code. So let's look at our old code before we had this really long try block. If we convert it to using the with keyword, it's going to look a lot shorter. So with open test.txt as f, write boop. And I still have to wrap this in a try except block, because if this open fails for some reason, then there's nothing that's going to catch it. So we're going to do try and except there as well. Yes, with itself is internally implemented with something similar to just another try except finally block, but a lot of those details are already implemented for us and hidden away from us, so we don't need to worry about them. So it makes life a little shorter, makes our code a little shorter. It'll probably make your life longer because you'll be happier. Yeah, sorry, that was okay. Let's get into the demo. Okay. So we had our file IO here. I'm just going to use the with syntax we've been talking about just to prove that it works. So with, let's just say open a new one. Let's call it Eric. Eric is cool.txt and write mode as f, and then f.write. Eric is super cool. Actually, when I say it like that, it sounds sarcastic. It's not meant to be sarcastic because he is cool. All right, when we execute this program, we get this. Oh, what did I do? This does not. Oh, because I have an exception. Okay, let's pretend like this exception didn't happen. Okay, I commented it out. All right. I think the code still ran anyway. Yeah, the code ran. We have some reading stuff going up, but before we created an Eric is cool.txt. So we look here, Eric is cool.txt has Eric is super cool. And this is really flexible too. I've been only doing this with text files, but if you did something like open Eric bench.py and in write mode, and then like f.write print I bench 135, something like this. If we execute this, we get this new Eric bench py file, and it has like Python code in it. So, very powerful, very flexible. All right, and then of course we can also wrap this in a try except block. So if I just wrapped it like this, try except, try except exception and print like, oh no, error occurred during file IO. It will catch that. So yeah, and if we run this will work as well. If it doesn't work, it'll catch that exception. Yes, so that is it with file IO. Are there any questions about that? Oh, I just looked at the chat. I'm not trying to kill you, Jakob. I'm not trying to. Maybe I am. Okay. All right, last poll, and then we will go on a break. So let us launch the poll. So I will, what is the steps? Pause recording. Okay, I resumed the recording just in time for the break slide. All right, break time. I'm sorry, I'm spoiling your slide, Eric. Let us take a break. Let's take a break for 10 minutes. Does that sound good? Resume at 7:12. Eric, is that okay for you? All right, let us resume at 7:12.
Okay. All right, so now it's finally time to learn about time. So you guys might be wondering what the point of using time in Python is. And obviously one application that we're going to be going into later on is going to be scheduling. But besides that, you might have some sort of program where you want to like print out the date, for instance. And time is really going to help accomplish this. Okay, So the first line that you'll need to write whenever you want to use time is import time. So as Jody covered in the first part of this workshop, this is essentially just importing the time module. And that way you'll be able to use the functions that we're going to be going over today. The first function that I'm going to cover is time.time. So as you can see, in the very beginning, it uses the module name. So in this case, time, and then .time. So time itself is also the method name, which is sort of confusing. So watch out for that. And when you run this line of code, what will actually be returned is this really long looking number. And you might be wondering, like, what does this really represent, right? Because it kind of just looks like some mumbo jumbo right now. And it turns out this is the time in seconds since 12 a.m. January 1st, 1970 UTC. So this might seem like a really random time period to begin at, but just a fun fact, it's actually the Unix time epoch, something along those lines. However, another method that you can use in time is time.ctime. And what ctime does is it actually returns you with a more readable format. And in this case, the example that I have here just gives the date and time. This is actually when I ran the line to create the slides. So these are two main formats for time. So one of them is just in terms of like seconds, while the other one is just more formatted. All right, so now that we have these two formats, we can also talk a bit about how you can convert between these two formats. So let's say that I have a variable t and I set it to time.time, which if you recall is just the time in the seconds format. I also have another variable called readable t, and instead of just setting it to time.ctime, I'm actually passing in t as a parameter to the ctime function. So this is basically going to convert from the number of seconds into the actual readable format, and it's going to store that readable format within readable t. So then once I try printing that out, you'll get something along this line as well. So now that we've gone from the seconds format to the date format, you're probably wondering, oh, can we go the other way around as well? So something along these lines, if we had readable t and then passed in readable t to the time function, sorry, this should say readable t. However, this is actually not possible. So you don't have to worry about this at all. You can actually only go from the seconds format into the date format. So there's many advantages of these two formats. So for the date format, it's obviously more readable, and to the user, it's going to make a lot more sense. However, if you have the seconds format, it's a lot easier to do some calculations. So if you're trying to like measure some time period, it'd probably be easier to use the seconds format, and then you can subtract two numbers or whatever to easily find the time that passed between them. So as I mentioned, one of the applications of time that we'll try to cover in this workshop is scheduling. So scheduling literally just refers to trying to make your program do something at some later time. For this workshop specifically, the problem here is that Eric or I spend too long scrolling on my phone between workouts at the gym. So this is a problem because after I hit a nasty set, I'm sitting there on my phone and I just get carried away by my Facebook feed. And 5 minutes later, I realize, oh, wait, I still have to hit my other sets. So the solution here, obviously, is to schedule a reminder for myself to stop being lazy. Now let's go into a quick demo to see how I can accomplish this. So here I just have a file named time.py. And as I mentioned, we first have to start off by importing time. Next up, I'm just going to go over some of the examples that I showed in the slides. So let's start with the time function. And keep in mind, time since 12 a.m. January 1st, 1970. And I'm also going to have a readable version of that time if I use time.ctime. And just to see that this works, we're just going to print both of them out. So when I run my code here, you'll see the first line that's printed out is this long number of seconds. And the second one is this more readable format, which if you'll notice is actually the time that it currently is. So I'll just go over a quick example of the cast as well. All I have to do is just pass in t as the parameter to the cTime function. And the output does not really change since I'm converting the same time back over to a readable time. Okay, now that we have a good grasp of what these two methods do, let's look into how I can actually start scheduling things. In order to actually schedule things, we'll actually have to use another method, which is called time.sleep. So what time.sleep is going to do is it's basically going to tell your program to pause for a number of seconds. And to specify how long you want your program to pause, you literally just pass in the number of seconds as a parameter to the sleep method. So in this case, if I want my program to pause for 3 seconds, I could just pass in 3 to this method right here. And I'm just going to print out some lines to demonstrate this, since if I just make a stop at the very end, probably won't really be able to notice that. So I'm going to print started and then pause for 3 seconds, and I'm going to print end. So you see here in the terminal, it prints started, and 3 seconds later, it's going to print end. Now, as I mentioned earlier, one of the reasons why we want to use the seconds format is because it lets us do some calculation in terms of like how much time has passed. So let's try doing that right now. I'm going to have a variable called start time, which I'm going to just set to the number of seconds before the sleep function. And then afterward, I'm going to have another variable called end time. And once again, this is going to be set to just the number of seconds as well. So now instead of printing end, I'm going to print start minus end equals, and then followed by the end time minus the start time. So I'm just casting this to a string in order to concatenate to the rest of the print statement. But what you'll see here is it's going to print started, and then 3 seconds later, it's going to print start minus end equals this number right here. So you might be wondering, since I paused for 3 seconds, how come the start minus end isn't exactly 3 seconds? Well, there's a lot of like complicated reasoning behind this, but just a few of them. One would be that obviously your instructions take some time to run as well. And also it has to do with how time is tracked in your computer, which we won't be going in depth into in this workshop. Okay, so now let's go back to the original problem of trying to make me stop wasting time at the gym. I'm going to comment this out for readability for the later parts. So let's say that after a workout, I want to take a rest for, let's say, 60 seconds. Well, one way that I could solve the problem is I could literally just make a countdown that counts down from 60 to 0 for me. And that way I'll know when my rest time is over, right? So how we can do this, we can first have basically like a counter variable, which will count the number of seconds left. And while the count is greater than or equal to 0, I'm going to print out the count. So this is basically going to tell me how many seconds are left. However, if I just ran this code right now, you'll see that it just prints 60 over and over. So I also need to decrement my count each iteration of the while loop. Still, when I run my code, you'll see it prints out 60 over and over. However, we also need to include some sort of interval between printing out the count variable and decrementing it, since if I were to just run this code, it will just not have any actual time implemented within it. So if I run time.sleep and then 1 second to basically create like an interval of 1 second between each of these prints and decrements, once I run this code again, you'll see that it starts counting down from 60, which is exactly what we needed to do. Okay, so that was quite a bit of content. So I'm going to launch a quick poll just to see if you guys have a good grasp of what's going on. All right, this is sort of just a reminder. If you guys have any questions, feel free to drop them in the chat, and either I or one of the other mentors will answer your question. All right. So now is come to the fun part of the workshop. It's time for the code along. So why I have this image here is basically throughout this workshop, you've learned a lot of different exercises, a lot of different ways you can do things in Python. And now this sort of like the final boss is like hitting your new personal record. We're going to try to like put it all together and work on this project. So what is the project, you might ask? Well, the project that we're going to work on is a text bot that's made with Twilio. So what Twilio is it's basically a company that provides this service, which allows you to send text messages and emails and such. We're just going to be going over the text demo, since all of this is going to be like completely free and like everyone should be able to follow along. On the right here is basically like a final example of what you'll end up with. Basically, you can get your Python code to eventually text you some cool things like this, like get big. And yeah, let's get into the demo. So first of all, we're going to start with some setup of Twilio. You're going to want to make an account at this website right here, which is www.twilio.com. So if you'll see here, basically you go to sign up and fill in some info. They'll then send you like a email confirmation, and you'll also have to do a confirmation for your phone, since we're going to be using your number as like the receiving end of this demo. Yeah, so after you get your SMS enabled Twilio phone number from Twilio, so what that means is Twilio will basically provide you with this like fake phone number that you can send texts from to yourself. And we'll give you guys a bit of time to set this up. What you should end up with is something along the lines of this screen here. I blurred out like all the information, privacy's sake, but this is what your dashboard looks like on Twilio. And the most important parts that we'll be using are the account SID, the authentication token, and also the phone number. Yeah, so we're going to give you guys a bit of time to work on this. But in the meantime, let's also go over another part of this demo, which will be necessary for the later setup. So this is a quick interjection about installing files, since later in this demo, we're going to be doing a bit of installing files. The two tools that we're going to be using are Brew and Pip. And basically what they do is, well, they help you install files. In fact, pip literally stands for pip installs packages, which is like this recursive definition of like pip. In general, these two tools are used to help manage your packages. And what that means is you can basically import files that don't exist on your local computer. And then you can basically use those files in your program, similar to how you would use modules that are on your computer. Pip and Brew are similar to npm if you've used that before. However, if you haven't, it's fine. And some of the difference between the two is that pip is only going to be used for Python, and it actually comes pre-installed with Python, I believe. And also Brew can only be used for Mac OS. In the later slides, we're also going to have the instructions for Windows. So don't worry if you're not on a Mac. If you want to learn more info about the difference between the two, I have this link here on the slide, which goes to a pretty interesting article about it. Okay, so since this is sort of the first time that we're experimenting with some sort of code along, I want to like get to know what you guys would prefer. Would you guys prefer that like we wait a bit more for you guys to finish with like all the Twilio setup, or would you prefer to like keep going with the workshop? You guys can just respond in the chat. So good as in like you have it set up. Okay, the question is, do you guys want to wait for everyone to like finish setting up, or are you guys good with me going ahead and you guys can like sort of catch up after you guys are done setting up? Okay, so let's wait, let's say like another minute or so. Okay, hopefully you guys have things mostly set up. If not, it's completely fine since for the later sections, which actually like require coding, we do have in the GitHub basically this starter py file that you can use, which all you really need to do is like fill in some info from your Twilio. Okay, so moving on. Next up, we're going to have to install the Twilio command line interface. So this is sort of complicated if you've never heard it before, but basically this lets us use some of the things that Twilio has provided for us. So we're going to run these lines in terminal. On Mac, it's going to be brew tap twilio /brew ampersand brew install Twilio. And on Windows, it's just going to be npm install twilio-cli-g. So if you're working on something like VS Code, you can just write it in like the terminal here. So I believe the line is brew tap twilio /brew and brew install Twilio. I'm not going to run it since I've run it already. But yeah, this is the line for Mac. And Windows, you just write npm install twilio-cli-g. Okay. After that, you're going to want to install the Twilio helper library. Once again, this is just another part of the Twilio setup that will let us use the Twilio module for our code. And as I mentioned earlier, we're going to be using pip. So pip, all you have to write is pip install Twilio. So same thing here on the terminal, you just write pip install Twilio. Okay. After that, we're good to go and we can start coding and using the Twilio library. So for this part, once again, we would encourage you guys to actually code along, even though in our previous workshops, we said don't code along, like listen to the info. This is one of the times that we actually want you guys to get something out of this workshop. So we would recommend that you code along. But if you don't have the time or you're having trouble setting things up, we also have the file set up in GitHub. So if you go to like our README link, you should also see on that same page, we should have a twilio.demo or twiliodemo.py file there for you guys. Okay, so I have that same twiliodemo.py file here, and I'm going to start the code along, I guess. So the first thing that we're going to want to do is to import the Twilio module, basically. Specifically, we're going to write from twilio.rest import client. And client is basically all we're going to need for this demo in terms of the Twilio side of things. And since we're also putting everything together, we're also going to import time. Now, I'm going to have an additional line here, which is import config. You guys won't need this, but basically config is this py file that I have, which has like all of my account SID authentication token stuff, since I don't really want to leak that. And I'm just going to import config and use those values from the config file. However, you guys can just directly put your values in, since you guys probably won't be like sharing your code with anyone else. But if you do, try to anonymize it. Okay, so first of all, we're going to just set up our variables. So we start off with the account SID, and you should actually just put your account SID here separated or in a like string. However, for me, I'm going to use config.account SID. And next up is going to be the authentication token. So once again, you can just put it in as a string, but for my case, I'm going to be using the config file. So next up, we're going to be creating basically a client object that we're going to use later on. So I'm just going to call this Twilio CLI is equal to client. And it takes two parameters, which are the account SID and the authentication token. And next up, we're also going to have to set up the phone numbers. So you're going to have two phone numbers that we're going to be working with. The first one is the Twilio number. And the next one is going to be your number. So when you're inputting these numbers, you should be able to just like copy paste them from Twilio, since they have like a little button right next to it that you can copy paste it. But for the numbers, make sure you have like the +1 in front of them, and also just store them as a string. Okay, so now that we have all of this, next up, let's actually try sending a text message. So how you would do this is you would write the line message equals Twilio CLI dot messages dot create. And here you can see it's going to take like a bunch of parameters, but most of them are going to be optional. The ones that we care about, first of all, we're going to set the body of the text. So in my case, I'm just going to make the Twilio thing text me get big, and It's also going to ask you where you're sending it from and sending it to. So to specify the from, it's going to say from underscore equals my Twilio number or whatever you chose to name your variable. And the to is going to be your phone number. Okay. So now if I try running this code, it should have worked. It takes a second, I guess, to do like the setup, and it should send me a text message. So I don't know why it's not popping up on my computer, but if you can see on my phone, oh, I got a text from the Twilio number, which says get big. Okay, so this is cool and all, but I have yet to solve my problem of not wasting time at the gym. So now let's go over an example that will use time. And so first of all, let's define the workout that I'm going to be hitting at the gym. So, since I'm trying to hit 135 on the bench press, obviously I got to do bench press, but some other chest exercises I do, incline dumbbell press is a good one, and also chest press machine. All right. So now that I've defined these 3 workouts that I want to do at the gym, now I can just write basically a for loop for exer in workout. And I'm just going to copy paste this message right here. So this basically sends a message. And instead of the body being get big, well, first of all, I'm going to want to tell myself to start the exercise. So I'll write start plus exer. And then let's say that I'm really strong, I can finish one set of the exercise in 3 seconds. Well, all I need to do is time.sleep 3 seconds. And then I'm going to send myself another text to start a break. So obviously after every set, you got to have some rest. So I'm going to write start break. Now, I got to keep my breaks at the gym short because I don't want to waste time while I'm at the gym. So I'm also just going to give myself a break of 3 seconds. I'm going to comment out this message here just because we don't need it anymore. And yeah, now if I try running my code, once again, it takes a second. But now what's actually happening on my phone is I'm actually getting texts telling me to start my exercise and then start my break. Well, it looks really weird with this background. But yeah, I'm getting spammed by this Twilio phone number to do my exercises. All right, so this was just a quick demo of how Twilio and Time can both be implemented into a text bot. And sadly, with the Twilio free version, you're not able to text other people, and you're not able to do emails as well, but there's a lot of capabilities here if you guys want to dive into them more in the future. All right, so that was the majority of the workshop. If you guys have any questions on the TextBot demo and such, you can stay, and we will also be opening breakout rooms if you guys need specific help from a mentor. But please, please, please fill out our feedback form here. It really helps us improve our workshops. And additionally, I heard that there's like money involved. This is sort of like a secret. So yeah, guys, fill it out for some potential money, I know the mindset is like, oh, well, there's too many people filling it out, like what if I don't win? Well, if everyone has that mindset, you're going to be the only person filling it out and you have a really good chance of winning. So who knows, guys? Yeah, fill out the feedback form.